Okay, so in this case, we've got white phosphorus, P4, and that reacts with KClO₃, so potassium chlorate, and that produces P₄O₁. So that's phosphorus pentoxide, I guess, phosphorus pentoxide, and potassium chloride. We've been asked to calculate the mass of P₄O₁ produced from the reaction, right? Okay, so in approaching this, one of the things I'm going to consider is the fact that we've been told that KClO₃ is in excess. The implications of that, right? So one of the key implications would be the fact that the amount of P₄O₁ produced is going to be effectively contingent on the amount of P4 available rather than on the KClO₃. And the assumption we're going to make is that all of the P4 reacted to produce the reactants as part of this reaction. Okay, so if we did want to calculate the mass of P₄O₁, generally speaking, the equation that would link mass, moles, and molar mass would be what? It would be M mass is equal to the moles multiplied by the molar mass, right? Now, out of these values, what do we actually have? Well, we've got the molar mass in some sense. We don't have it directly, but this is something that we can quite straightforwardly work out from the periodic table. But the number of moles we don't have, and it's not as seamless to figure out. So, but one of the things we can do is for this P₄O₁, we can actually work out the moles in an indirect kind of way. So we can effectively use a comparison. So we can compare it to the moles of P4, and based on the how they compare as far as the amount of substance in the balanced equation, we can use that information to work out the moles of P₄O₁. Now, with regards to P4, we don't actually have the number of moles at this stage. We're going to try and work that out, but we do have the mass. So if we consider the equation that links the moles, mass, and molar mass, but with moles as a subject, so if we divided both sides of this equation by the molar mass, you would have M over MR, right? Effectively equals N. So that's effectively the number of moles is equal to the mass divided by the molar mass, right? So you can, figure that one out. But so in this case, for the P4, the moles of P4 would be equal to the mass, which is 42.11 divided by the molar mass, right? And we don't have the molar mass just yet, so I'm just going to put MR there, but that would be the MR of P4, right? But we're going to go ahead and figure that out from the periodic table, right? So you can see phosphorus, we've got phosphorus here, so P4, so the MR of P4, so that would be effectively the relative atomic mass of the phosphorus multiplied by its frequency of occurrence in the given formula. So that's going to be 31 multiplied by, and then you can see the coefficient of 4, so it's going to be times 4. right? And so that is effectively going to give us the molar mass of this particular white phosphorus. Now, if you had a go at working that out, what you should have found is that the molar mass would come to 124. Then for the units, right, that giving it some molar mass, grams per mole, right? Okay. Now the other thing here is well, let's just move on to so let's do this part first. So 124, let's plug this in effectively. So 42.11, and we know now that the MR of P4 is the 124, right? So we just plug that in, and this is going to give us our number of moles, right? So if you work that out, what you should find is you get 0.3395 968, and that's going to be in moles, right? Okay, so we've got a value of moles now for P4. We need to refer back to the equation to understand, well, what's the significance of this in relation to our goal of working out the mass of the phosphorus pentoxide, right? Well, let's compare the molar ratios, okay? So I'll just set this up below, but then we're going to look at the equation again. So the number of moles of P4 compared to the number of moles of P₄O₁₀, right? No. O10. See, if you wait, okay, so now if you look at the coefficients, right, you've got a coefficient of 3 here and a coefficient of 3 here. What would be the implication of that, right? Well, what this tells you is that for every 3 moles of P4, you're going to have 3 moles of P₄O₁, okay? So if I write that down below here, for every 3 moles of P4, I'm actually going to have 3 moles of P₄O₁. Now this is a ratio, so I can simply divide the both values by the common one of the common factors, which is 3. And if I do that, I'm going to get 1 to 1. And what does that tell us? Well, it tells us the number of moles of P4 and the number of moles of P₄O₁ is the same value, right? So therefore we can say that the number of moles of P₄O₁ is equal to the number of moles of P4, right? Which is, as we know, is equal to 0.3395968, right? Okay, so, but remember, our goal from the question as well is to figure out the mass of P₄O₁. And we know from the equation here that the mass is the moles multiplied by the molar mass. We've got the moles, but we don't have the molar mass. So we're going to need to work that out. What's the molar mass? P₄O₁, right? So if you refer back again to the periodic table, so okay, well now we're going to try and work out the molar mass of P₄O₁, right? Well, that's going to be equal to So for phosphorus, we've got 31, right? So that's going to be 31 times 4, right? And then for oxygen, we've got 16, right? So 16. So that's going to be 16 times the relevant coefficient here, which is going to be 10, right? And so if you work that out, that's going to tell you what the molar mass for the P₄O₁ is going to be. And if you work that out, what you should have found is that gives 284, right? And that's going to be grams per mole, right? Now at this stage, that 284, if we go back over to here, and we apply that equation, now we're just going to write it here again so we don't have to scroll up or anything, but this is simply the fact that the mass is equal to the number of moles multiplied by the molar mass, right? So in this case, that's going to be effectively the mass of P₄O₁ is going to be equal to, so we've got the moles here, right? So that's going to be 0.3395968, and we need to multiply that by the molar mass. So that's going to be multiplied by 284. Yeah. And if you work that out, what you should find is that you get 96.4455712, and that's going to be in grams, right? Okay, so again, if we look at the question, the mass is what we've been asked to work out, right? And so we have a mass here, so for the P₄O₁. So we've made significant progress on the question, but importantly, we do need to pay attention to what it requests us to do with the answer, a maximum of 2 decimal places, right? So we do need to make sure that this is in that format. So what we're going to do at this stage is that's going to be therefore equal to 96.45, okay? And that's going to be in grams, so 2 decimal places. All right.